which is positive 16. So negative 64 to the 2/3 power is 16. Okay, so let's do one more, but this time with a fraction. And yeah, I'll do it under here. Okay, so what if we wanted to simplify or solve, whichever way you want to put it? Let's say negative 1/25 to the 3/2 power. Oh, make sure that's okay. Now this time the negative is on the outside. So as long as the negative is on the outside, it's just like saying -1 times that. Okay, so you have negative 1/25 to the 3/2 power. Okay, so that would give you negative. You can remember from the power of a quotient rule, you can just distribute that to both. So you have 1 to the 3/2 power divided by 25 to the 3/2 power. Oh, clean that up some. Okay. So 1 to the any power is automatically going to be 1. It doesn't matter if it's a fraction, decimal, anything at all. 1 to the power of anything is 1. Okay. So we have -1. With this one, remember you can get your 3 and bring it to the outside. So you have 25 to the 1/2 power cubed. Uh-oh, straighten that up some. There you go. Okay, which ends up equaling, remember you still have your -1 over the square root of 25 to the 3rd power. Okay. Now even though the square root of 25 is either positive or -5, we're going to mostly stick to the positive value, so you don't have to put positive or negative. Okay, so -1 over 5 to the 3rd power, which gives you -1 over 5 times 5 times 5 is 125. Okay, so that would be your final answer. All right. Any questions on that one? All right. Okay, no one's still writing. Nope, looks like everyone's done. Okay, so now we're going to be simplifying radical expressions. Okay, so far we've had just like single terms, so now we're going to simplify entire expressions. Okay, so the steps that would kind of make this easiest are the first thing you're going to do is you're going to change the radical expression to an exponential one. Oh. So all that means, for example, is you're going to change the cube root of 5 to 5 1/3. So from an exponent to, from a radical to an exponent. Okay. So next, you're going to simplify the radical expression. And that just means you're going to use distributive property, combining like terms, things like that. Whichever one that particular problem happens to need. Okay. And third, you're going to change it back to a radical expression if necessary. So change the exponential expression back to a radical if necessary. Okay. So if they say give your final answer in the form of a radical, then you change it back. If it says give it in the form of an exponent, then you'll keep it that way. Excuse me. All right, so let's say, for example, if you wanted to simplify, say, 5 to the 2/7 power times 5 to the 3/7. Okay, so if you remember, a to the m times a to the n equals a to the m plus n. So that means 5 to the 2/7 power times 5 to the 3/7 power is equal to 5 to the 2/7 plus 3/7. Which, since you have like denominators, you just add your numerators. All right. So any questions on that one? All right. Okay, so let's say, for example, let's say if we wanted to simplify, say, 11 to the 2/7 power, and that raised to the 3rd power. Okay, so for this one, we have a to the power of m, and that raised to the power of n equals a to the m times n. Okay, so we know that 11 to the power of 2/7 cubed, which is the power of a product of a power, not power, product rule, the power, yes, power rule. Forget the names of them sometimes. Okay, so that's just 11 2/7 times 3. Okay. If you want it, you can make the 3 3 over 1. Which is 11 to the power of 2 times 3 is 6. 7 times 1 is 7. All right. Any questions so far? Okay. Kind of separate those. Okay, so let's say, for example, we wanted to simplify, say, a to the 4/5 power times a to the 1/5 power plus a to the 3/5 power. So it's already in exponential form. So now we just distribute. So a to the 4/5 times a to the 1/5 plus a to the 3/5. It's going to equal a to the 4/5 times a to the 1/5. Uh-oh, wrong one. Plus a to the 4/5 times a to the 3/5. Okay. So we know just from this rule up here, we're multiplying with the same base, we just add your exponents. Okay, so that means it's a to the 4/5 plus 1/5. Plus a to the 4/5 plus 3/5. Okay, so it ends up equaling a to the 5/5 plus a to the 7/5. Okay, which is equal to a to the first power, or just a, plus a to the 7/5. Okay, you actually can't combine those because it would be like combining x squared and x. They would have to be exactly the same to combine those two. So that would be your final answer. Oh, bring that up some. All right, so any questions on that one? Oh, thought you had a question. Okay, so you want to leave that up for a few seconds. All right. Okay, so let's say, for example, we wanted to simplify, say, a to the 8/3 power times a to the 1/3 power over a to the 2nd power. Okay, so this one you can kind of solve it a couple of different ways, but mostly I found it easier to simplify the numerator first, then the denominator, and then kind of simplify it from there. Okay, so a to the 8/3 times a to the 1/3 divided by a squared. Remember, you can just, as long as the bases are the same, you can just add your numerators. A to the 8/3 plus 1/3 divided by a squared. Okay, which leaves you a to the 9/3 power divided by a squared. And 9 divided by 3 is just 3. Clean that up a little bit. Okay. Now you have your quotient rule. Remember, a to the m over a to the n is a to the m minus n. So this is going to equal a to the 3 minus 2. Which is just a. Okay. So all of that just simplified to a. All right. Any questions on that one? All right. Okay, so let's say, for example, you have 2x to the 1/5, and that raised to the 4th power, divided by x to the 3/10 power. Clean that, make it look more like a 5. There we go. Okay, so let's rewrite this. 2x to the 1/5 power to the 4th for x to the 3/10. Okay. So the first thing I would do is I would go ahead and use the power of a product rule and distribute that exponent. Because remember, it's a to the m raised to the nth power. Erase that second one a bit. Equals a to the m times n. So this just becomes 2 to the 4th times x to the 1/5 to the 4th power divided by x to the 3/10. Okay. This one, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, so 2 to the 4th power is 16. And this, when you have, use a bracket instead of parentheses. Remember, a to the, actually using the same rule over again. Actually, it should have been over there. That should have been the power of a product rule. So I'll put this here. A to the m times n equals a to the m times n. And this one actually should have been the power of a product rule, which is a times b to the n equals a to the n times b to the n. Sorry about that. Okay, so that one distributes the exponent. And this one just multiplies those two. So you have 16, x to the 1/5 times 4, which is x to the 4/5 power, divided by x to the 3/10. Now the 16, you can actually just factor that out to the front. Yep, give me a little extra room here. And now you have x to the 4th, 4/5, over x to the 3/10. Okay. And we know there just by the product rule, the quotient rule, say x to the m over x to the n equals x to the m minus n. So we'll pick that up over here. So 16 times x to the 4/5 minus x over 3/10 is x to the 4/5 minus 3/10. Okay. Which, you can't subtract until you have the common denominator. So you can multiply this one by 2 over 10. I'll put this on this next step instead of trying to squeeze everything in there. And I'll just add that at the bottom here. So 4/5 minus 3/10. We know if we multiply that by 2 over 2. Oh, make sure, yeah. We have 8/10 minus 3/10 is 5/10, which is 1/2. So this actually becomes 16 x to the 1/2 power. All right, so any questions on that one? Okay. Leave that up for a second. Okay. Let's say if we wanted to combining or simplifying radical expressions. Okay, so let's say if we have we know that 28 is 4 times 7. Or 54 is 27 times 2. Okay, let's say we even remember that the cube root of -8 is -2. Just those little details. Okay. So we can get that, and we can say square root of 28 is actually equal to the square root of 4 times 7. Or we can even say cube root of -8 is equal to the cube root, 54, sorry about that. Square root of 54. I'm looking at the wrong one. Square root of 54 is the square root of 27 times 2. Oh, sorry, it was cube root. I was right. Okay, so you could actually separate those. Okay, so in general, the nth root of a product of two numbers is equal to the product of their nth roots. So all that just says, in other words, let's say the nth root of a times b is equal to the nth root of a times the nth root of b. Okay. So if you have two values under here, whether they're variables, numbers, or anything else, you can separate them into two separate roots. Okay. So for example, our square root of 28. We know that's square root of 4 times 7. Okay. By this rule here, we can actually separate those. So it'll be square root of 4 times square root of 7. Now we know square root of 4 is either positive or negative 2. We're just going to use the positives on problems like this. So it's 2 times square root of 7, which is just 2 square root of 7. Okay. You can't really simplify the square root of 7 anymore because it's an irrational number, since that's not a perfect square. So you just leave it as square root of 7. All right, any questions on that one? All right, so let's say if we have the cube root of 54, which is our problem up there. Okay. So we can go ahead and just separate that as cube root of 27 times 2. Okay. Then we just break those apart. So cube root of 27 times the cube root of 2. Okay. So we know 3 times 3 times 3 is 27. 3 times 3 times 3 is 27. So that gives us 3 times the cube root of 2. Now, cube root of 2 can't really be simplified, so that's just 3 cube root of 2. All right, any questions on that one? Okay. Sure. Still writing. Oh. One thing you want to remember. You can separate multiplications, but you can't separate adding and subtracting like this. Can separate of radicands, but not addition or subtraction. Okay. So for example, you have the square root of x plus 4, it's not the same as square root of x plus square root of 4. Okay. Or x minus square root of x minus 4. You wouldn't be able to separate them. Looks like you should, but you can't. Okay. So let's say if you, just to give an example of why it wouldn't work, let's say square root of